It's working. Thank you very much for joining this presentation. I'm Cristian Cornea, and we are going to discuss about how can we bypass antivirus solutions using BadUSB. For those who doesn't know, BadUSB, it's a small device. I forgot to take it out, but 1 second. So it looks like this, small device. You can do nasty thing with it. And we'll show today how you can use it to trigger a reverse shell, even if the antivirus is being run on the target computer. Okay. Yes. So, two words about myself. I'm certified with some of the offensive security certifications, also founder of the Zero Touch Security, which is a cybersecurity service provider, and founder of the National Cybersecurity Training Center in Romania, trainer for different companies and entities, including Pentagon, Slovenian National Bureau of Investigation, Polish CERT, and so on. Speaker at multiple conferences and part of the ASI Council Czech Scheme Committee, which means that I'm part of the group that writes the syllabus and exam questions for that exam. And as a side note, I'm not responsible for the Nmap questions, if you know what I'm talking about. Yeah. So the agenda for today, it's pretty simple. We'll see how AMSI can be bypassed, what is AMSI, an introduction to AMSI, what is execution policy and how can we evade it, and how can we develop every bypasses that we'll discuss into a runner in order to have our payload fileless. What is a fileless payload? It means that we don't download anything, we don't pull anything from a remote location to the victim computers. So all the payloads will be run directly into the memory. Then we put together everything on this little device, which is the BadUSB. Then some post-exploitation persistence, a live demo with Windows Defender up and running, and some prevention tips. All of those will be done against a lab computer that has Windows Defender up to date, and also it is running a low privileged user. So how we'll do it, we'll see during the presentation. But firstly, what is the scenario of our attack? Or what are the common scenarios that we can meet in real life? And we have met them multiple times. So Bob is a normal employee. He goes smoking in the parking lot, and Bob's found out this little device near his car, and he takes the device. It's not theoretical, it's a real life scenario. So that's even worse. So it takes the little device, goes up and plugs it into the corporate computer. What happens next is that a program was run on Bob's computer. It was lightning fast. Bob never noticed any difference to his computer. So the computer returned to its normal state of work after 1 millisecond. And basically an attacker is now connected to Bob's computer. But how it happened? Because Bob has Windows Defender enabled and up to date. The user that Bob is running under is a low privileged user. And basically they have a policy, organization-wide policy, to disallow removable media storage. So how it was possible, we'll see during our presentation. Okay, so the sequence of attacks are the following. This is what we'll do on our little BadUSB. Basically, we'll have an AMSI bypass in order to trigger an evasion for the antivirus, an execution policy bypass. how many of you run into issues with execution policy, or how many of you heard about the execution policy on Windows? Okay, perfect. So, as a summary, the execution policy on Windows is the policy that allows or disallows PowerShell scripts to be run under a low privileged user or under some users. And we'll see how can we bypass that one. Then we need a method to inject our payload, all the payload into the memory in order to be fileless. So we are moving stealthy and we are playing only with the processes. Then some post-exploitation tips and techniques. Before moving into the technical details, before moving into the actual exploitation process, let me ask you a question here. How many of you still rely on an antivirus to protect their organization, your organization, or your personal computers? Okay. How many of you rely on an ADR solution to do that? Okay, perfect. How many of you are confident into having just Windows Defender? Okay, that was not expected. So I will give you a reason now to not be confident in that decision, because you'll see how bad it can act. So let's go directly into the techniques. The AMSI-Bypass technique. Basically, what is AMSI? For those who doesn't know, AMSI is like a middleman between your computer and the antivirus engine. Whenever third-party solution provider for antiviruses wants to implement an antivirus within your Windows machine, they basically disable Windows Defender and they enforce only that antivirus. It is because of the AMSI. So you cannot have basically 2, 3, 4, and 5 or more antivirus solutions. You can have just one, because that just one is using AMSI. Basically, is being used by AMSI. AMSI is a library, AMSI.dll, that uses the AMSI scan buffer function. That function is used to analyze, to push for analysis of the PowerShell scripts that we are running on the computer. Basically, what we'll do in our technique, we'll manipulate this AMSI scan buffer. So we'll play with this function and we'll make it to return basically true every time it runs. Not true, but we'll make it to return a specific value. That value will be like a bypass for the analysis engine within Windows Defender. So, okay, this is the first step into building our payload. As you can see here, this is not PowerShell. This is not PowerShell code. Basically, we can use C style code into PowerShell with add type. So we can use the add type within PowerShell. It's a function that allows us to translate C type code into PowerShell. And here we define three functions, native functions within Windows. So we define get proc address, load library, and virtual protect. You may assume that we'll use those functions within our AMSI bypass. How we'll use it? Basically, get proc address is used to pull the exact memory address of a specific function within memory. How can we search for a specific function within memory if we don't know the library that defines that function? So we have the load library function, which basically loads the memory of the memory address of a specific function. And then the virtual protect will be using it to edit the function itself. Also, this process is called patching. So we are patching memory addresses and return addresses within the memory. And for that one, we'll use a virtual protect. Okay, the third step will be to search for the AMSI scan buffer. As you've seen here, we loaded the AMSI.dll using the load library that we defined previously. So now we are searching for the AMSI scan buffer function that we discussed. We need to patch. We need to replace its return address. And here we have. This is the return address that we will patch the AMSI scan buffer function with. And why this value? We'll explain during the next 2 slides, because it's basically not random, so it's not a random value. It's taken from the documentation. And here, using the Marshall copy, we can patch the address. So why the value here? Why this value? Basically, if we are taking a look over the AMSI scan buffer function, Microsoft official documentation, it says the following, quoting Microsoft. If this function succeeds, it returns SOK. Otherwise, it returns an H-result error code. And here we close the codes. But it's not completed. This explanation is not completed. Why Microsoft didn't tell us that if the function returns an H-result error code, then the script is actually executed? Microsoft never told us about it. So, if the function is for the function, if we do not provide the arguments, if we do not provide the correct values for it to run, it will pass the script, the PowerShell script, directly to execution, which is a very, very big mistake. And they never documented this issue, and is still not documented. So, our goal here, our mission here, is to make the AMSI scan buffer to return H result every time it runs. H result will be this value. Why this value? Basically, if we take over the H result values within Microsoft official documentation, we can take anything from there. So any value from the table of H result values. And I took here the first value, which says one or more arguments are invalid. Basically, it's any value that you can take from the H result values. And let me show you on Google right now, because it's on Google. Result Microsoft. Okay, it's loading. So as you can see, we can take any from here. Let me make it a little bit. Perfect. So you can take any value from here. The table is pretty big. So those are possible values for the H result value. So you can take anything from there, but be aware of the characters, because some operating systems would crash on bad characters. So the value that you take, before that, how many of you have buffer overflow experience? Okay. As you may know, in buffer overflows, you test for bad characters, because some characters are interpreted wrongly by the computer. The same here. The value that you take here must be interpreted correctly. Some of the characters can be considered bad characters. So this value, for example, was tested and it is interpreted okay in more than 10 versions of Windows that I have tested within the lab. So we have here the AMSI payload. Let me ask you a question here now. This is detectable. How can we make it undetectable or less detectable? Yes. Basically, you are very close. It's obfuscation. So it's obfuscation. You can add any layers of any types of obfuscation. Here we obfuscated the code using normalized functions and using hexadecimal characters. So everything is basically obfuscated, but be very cautious on this one. This code cannot be obfuscated too much because it's in another language, it's in C, so when you use the add type function, it will not translate the code correctly into the PowerShell. So what code can we obfuscate is the one that is PowerShell only. Okay, so we have the AMSI-Bypass technique. Let's see execution policy bypass. I think many of you run into this error. So this error tells you have no rights of running PowerShell. But do you have the rights? Because you can use something like set execution policy unrestricted with -- scope current user, which will allow you to bypass the execution policy within the scope of your current user. Which means that if we are Bob, and we type this command, it will make the execution policy to allow the PowerShell scripts for our account, but for our account only. So it's pretty standard. We were discussing it with Microsoft, and the Microsoft answer was, it's a feature. So yes, it's a feature. It's a feature for both service administrators or system administrators, but also for attackers. So it's a feature, good feature. Thank you, Microsoft. Okay, so that was it. You expected something fancy and complex, but no, it was just like that. So how can we develop the payload runner? Basically, the payload runner will help us to inject everything into the runtime, into the memory. Basically, here we start our payload with the lookup func. This function is using to search some assembly references within the memory, because the time is pretty tight. We won't get into too many details for this function. But for the get delegate type function is a function that is used to tell PowerShell, okay, you don't know about pointers, right? Pointers are not defined into PowerShell, but we need them to pass as arguments to some Windows API native functions. So the get delegate type function is used to set those argument types. So pointers, int32, and things of the nature. All of them can be set with the get delegate type function. Okay, next we need to allocate the required memory for our payload. As you can see here, the payload the shellcode is over 2000 bytes. And here is the allocated space. Basically, we need to be very cautious to allocate close space to the shellcode that we generate. Do not allocate less space because obviously the shellcode will not run. And here, for the purpose of this demonstration, we will use an Windows x64 Meterpreter reverse TCP. So pretty easy to catch by any antiviruses, pretty detectable by any solutions. And it's also plain text, so behavior detection should catch it very, very easily. And next, using the same Marshall copy that we used to patch the address, we will use it to copy the shellcode directly into the pre-allocated buffer, and then just execute it, as you can see here, with the create thread function from kernel 32. And here we used the get delegate basically to set the integer pointer, integer 32, and other argument types for the invoke function. Okay, so that's it regarding the bypass and the shellcode execution. Everything it's good so far. But now let's see how we can put everything together on this little device. So, how basically the attacker, how he was able to run the BadUSB on the Bob computer, because there was a removable media storage policy in place. Basically, the attacker was not using a removable media storage. He was using a BadUSB. And a BadUSB is not a removable media storage. It's a mouse and a keyboard. Yes, it simulates a mouse and a keyboard. So it can write, type, and move the mouse pointer as you want. And how can we develop payloads on this BadUSB? How can we easily develop payloads? Because developing payloads on BadUSB, sometimes it can be pretty hard. But how can we easily work smart and develop good payloads on this BadUSB? Basically, if we try the hard way, if you have advanced knowledge in C++, you can use the Arduino native programming, basically, with the compiler and with some functions and libraries. But if we work smart, we can use Ducky script. How many of you heard about rubber duckies? Okay, perfect. Yeah. So, rubber duckies. Basically, for rubber ducky, there is a specific language to develop payloads for them. It's basically the Ducky script, and the Ducky script can be converted to basically Arduino scripts using the Duckwino on GitHub. So you can insert your Ducky script and convert it to Duckwino. So you can basically develop the same payloads that you would develop on a rubber ducky on the BadUSB, and then just insert it into the Arduino compiler, and that's basically it. Now let's see some syntax tips for the Duckwino scripts. Basically, those apply on the rubber ducky, but as we discussed previously, we can use the Duckwino to convert them to Arduino. So we have string. Anything that we type after the string command is basically typed by our BadUSB into the victim computer. We have delays. We can use delay if our target is basically slow, because BadUSB sometimes it can be faster than the victim computer. So we can use delay to sleep the typing of our BadUSB. Then rem for comments. Repeat works as a loop to repeat the last command. And the special keys like enter, control, tab, shift, things of the nature should be written within the script as they are written on the keyboard. And the guy is the Windows key. And we can control the mouse with mouse_move, and L mouse, R mouse, M mouse stands for left mouse, right mouse, and middle mouse are the buttons within the mouse. And some tips when you acquire such BadUSB. Basically, those BadUSBs are acquired from China in my example, and when I plug them into a sandbox, because it is recommended to have a sandbox. Yes, it's recommended to have a sandbox before actually developing on them. They had a reverse shell on them, so they were trying to spawn a reverse shell to some IP addresses. Like, obviously, those IP addresses were not Microsoft addresses. So I searched for them on Abuse IPDB, and they were like confidence score of abuse very, very high. So yeah, that's it. Just run it on a sandbox before starting developing it. Okay, and a tip when you do the post exploitation, basically for the thread, for the process to not close instantly, you could migrate it to another process, because we are doing it through Metasploit. So we are actually generating a Meterpreter reverse shell. So you can use the migrate command to migrate the process to something like explorer.exe or chrome.exe or something like this. Okay, so now the demo. I think this is the most awaited part of the presentation. So let me set up the things right now here. We will use a command and control within AWS right now. I hope I was not okay. Yes. The timeout within AWS. Just 1 second. Okay, let me show you that Windows Defender is actually running. Okay. So real-time protection is on. It's running. And let's connect to the command and control. Basically, this is just a Kali Linux hosted on the cloud. And for the purpose of this presentation, we'll use Metasploit, because should be detectable by any antivirus solutions. So it should be an easy to catch payload, but we will see. So it's loading the classic use exploit multi-handler. The payload that we set as a listener will be the same payload that we set during the generation of our shellcode. So set payload Windows x64 Meterpreter reverse _TCP. Okay, set listening host, L host. We'll put something like 000, so catch anything. Set L port. If you observe during the slide, we set the listening port to 443, so a common port. And now we just click run. Okay, we start the listener, and now is the time to insert the BadUSB. As you can see, here is the BadUSB. Okay, yeah, I didn't do anything. So we will insert the BadUSB as Bob did. And we wait. Okay, so, okay, so it's starting doing things. Now it's doing the get delete get type function. Now it's creating the payload. So it's placing the payload into the memory using the Marshall copy. It copied the payload into the memory. And here we have a shell, Meterpreter shell. And we can type any commands on it. So it's an actual shell with, for example, load Mimikatz. Okay. And here we have also Mimikatz. So with the Windows Defender running. As you can see here, the Windows Defender is running. We loaded Mimikatz. We have everything, reverse shell, Meterpreter reverse shell. And yeah, 1 second. Okay, so some prevention mechanisms for this type of attack. Basically, disallowing the PowerShell through execution policy is not enough. We should cut PowerShell entirely. So don't rely on the execution policy. Access control lists on the physical USB ports of the corporate devices. Switch from an antivirus perspective to an advanced endpoint protection, such as an ADR. And also security awareness for users. Don't pick USBs from the parking lot and insert them into your computers. Or if you find a USB in a backpack, don't plug it into your computer. So things of the nature. And some research and statistics. Basically, the same payload was executed against 20 antivirus vendors besides Microsoft. 7 from 20 spawned Meterpreter reverse shell, and it allowed Mimikatz to be loaded directly into memory. And 9 from 20, just a reverse shell. So the 9 antivirus vendors caught the Meterpreter reverse shell, but they allowed the reverse shell. And 4 from 20 blocked the attempt when we tried to use the add type within PowerShell. So that's basically it. Some questions? Yes, please. So this is Defender for personal computer. It's not enterprise. So this one is not enterprise. It's just Defender. The question was if this was Defender for enterprise or Defender for personal. But this is Defender for personal. It might work also in enterprise. It might work. Yes. Yes, so those types of attacks might not work against ADRs. The question was if they might work against ADRs. Personally, I think they might not work against ADRs because most of them are actually blocking like add type or C functions in PowerShell or things of the nature, or really the virtual protect. So things of the nature will not work. But this is just personal opinion. I didn't test it, so. Yes, please. Yes. So the purpose, basically, yeah, you can download it. So you can download directly the payload. But the problem is the payload. If you download it, it will be a file, right? You'll have an artifact on the computer, on the compromised computer. We don't want to have artifacts. We don't want to leave traces. We don't want to download things because the static analysis will probably catch us. So we want to move fileless. Moving fileless is more stealthy and more efficient than having files. And the problem that you've seen that it took some while into executing. I wanted to take some while because I wanted to show you that, okay, here is doing the payload, here is putting the buffer, but you can remove the sleep. So you can remove the sleep and it will be lightning fast. So it can be something in milliseconds. But I wanted to show you that the same payload that we are discussing is the same payload that is being run by the BadUSB. Okay, are there any other questions? Yes, please. Yes and no. So if you want to trigger it behind the Windows locked session, if the user has locked password, then it's nearly impossible. If the user has locked session but just the sign in button, it's possible because you can control the mouse movement and you can point directly on the coordinates of where the button of sign in is being set on the Windows. Okay, are there any other questions? Then thank you very much.